Dear students, I would like to present to you the concept of conditional expectation. Under this concept, we will be talking about the conditional mean and the conditional variance. तो पहला सवाल ये है कि what do we mean by conditional expectation? Students, it is like this. Suppose that ux2 is a function of x2, and given this, the conditional expectation of ux2, given that capital X1 is equal to small x1, some particular value, if this expectation exists, conditional expectation, it is given by the integral from minus infinity to infinity of ux2 multiplied by f of x2 given x1, and the integration is being done with respect to x2. अब ये जो कुछ मैंने कहा और आपके सामने भी है, इसमें कोई इतनी परेशानी की बात नहीं है. इट इज़ एज सिंपल एज दिस कि अगर अनकंडीशनल एक्सपेक्टेशन निकाल रहे होते तो आप लिखते माइनस इन्फिनिटी टू इन्फिनिटी ux2 इंटू एफ ऑफ x2 dx2. अब आपने f of x2 की जगह you are writing f of x2 given x1. यानी कंडीशनल एक्सपेक्टेशन अगर आपको चाहिए तो वो जो डेंसिटी फंक्शन वहां पे इंसर्ट करना है, दैट इज द कंडीशनल डेंसिटी फंक्शन. बाकी जो एक्सप्रेशन है जिस चीज का एक्सपेक्टेड वैल्यू जिसकी निकालना चाह रहे हैं वो आप वैसे ही लिख देंगे उसके अंदर. So, as you have noted, then it is not really so difficult. अब इसके बाद let us talk about the conditional mean. अभी मैंने आपको जो कुछ कहा उसमें ux2 can be any function of x2. फर्ज कर लें अगर हम कि ux2 is equal to x2, यानी वो x2 ही है अगर खुद ही, तो फिर क्या होगा? Obviously, we will have expected value of x2 given small x1 is equal to the integral from minus infinity to infinity of x2 into f of x2 given x1 dx2. तो ये जो अब मैंने कहा, obviously this is what can be regarded as the conditional mean. क्योंकि अगर वो given x1 साथ ना लिखा होता तो then it would have been the unconditional mean, expected value of x2. यानी unconditional meaning simple mean of the random variable x2. अगर conditional उसके साथ एक condition लग गई है तो फिर जाहिर है कि हम उसको conditional mean कह सकते हैं. Similarly, students, we can also talk about the conditional variance. So what will be the formula or the expression for the conditional variance? Again, first think of the unconditional one. Unconditional, simple variance of the random variable x2 would be written as expected value of x2 minus e of x2 and this whole thing raised to 2, right? तो ये था if it was the unconditional variance. अब अगर conditional variance कह रहे हैं तो हम कैसे लिख सकते हैं? As you can now see on the screen, it is the expected value of x2 minus e of x2 given small x1 and this whole thing raised to 2 given small x1. क्योंकि ये कंडीशन जो लगी हुई है वो हमने उसके अंदर necessarily incorporate करनी है. Now, since this is the conditional variance, we can call it or denote it by VAR, variance of x2 given small x1. अगर हम शॉर्टकट फॉर्मूले के हिसाब से चलें तो हम लिख सकते हैं variance of capital X2 given small x1 is equal to the expected value of capital X2 square given small x1 minus the expected value of capital X2 given small x1 whole square. Once again, you can see that it is exactly the same formula that we have for unconditional variance. यानी आम जो होता है shortcut formula for the variance of x, for example, is expected value of x square minus expected value of x whole square. यहाँ और उसमें सिर्फ ये फ़र्क है कि यहाँ ये condition जो है वो उसके साथ चलती है. And you have to write it with all those things. All right, now that I have said all this to you, I also want you to note कि अभी हम x2 given x1 कह रहे थे. अगर हम इसको उल्टा दें and we talk about any function of x1, u of x1 given small x2, तो वही सब कुछ होगा just in the other order. One more thing, that all that I have just said is with reference to continuous variables, but in the case of random variables which are of the discrete type, obviously these conditional expectations will be computed in a similar manner, but the integral signs will be replaced by summation signs. Let us now also look at an example. Suppose that x1 and x2 have the joint PDF f of x1 x2 is equal to 2, where 0 is less than x1 and x1 is less than x2 and x2 is less than 1. ये हमारा joint PDF है. अब अगर हम सबसे पहले marginal densities निकालना चाहें तो हम निकाल लेते हैं just by the usual method. f1 x1 will be the integral of this joint density function, where the limits of the integral will be x1 to 1 and the integral is being taken with respect to x2. x1 का marginal निकालना है ना, तो जाहिर है कि इंटीग्रल हमें with respect to x2 लेना होगा. और अगर आप गौर से देखें तो x2 जो है उसके लिए जो लिमिट्स बन रही हैं they are x1 to 1. तो इसको सॉल्व कर लीजिए and we get 2 into 1 minus x1, and after that we can write a comma, and after that 0 less than x1 less than 1 as the support of this marginal density function. इसी तरह we can find the marginal density of x2. This time again we have to take the integral of the joint density function, but this time the integral is with respect to x1 and the limits for x1 for this integral are going to be 0 to x2. तो उसको भी आप solve कर लें. So the answer comes out to be 2x2, and then we write a comma, and then we write 0 less than x2 less than 1. Marginal के लिए जो support बन रही है उस distribution की, that is 0 to 1. आप नोट करें कि x1 के लिए भी इसी तरह और x2 के लिए भी. लेकिन जो joint है उसमें जो important चीज़ है वो ये है कि we have available to us here 0 less than x1 less than x2 less than 1. Now that we have found the marginals, my dear students, we can also find the conditional distribution. If we want to find the conditional PDF of x1 given x2 equal to small x2, then what should we do? We should simply divide the joint density expression by the marginal of x2. So joint का expression क्या है? What is the expression? f of x1 x2 is equal to what? It's equal to 2. और जो marginal आया है x2 का वो क्या है उसका expression? It is 2x2. If we divide 2 by 2x2, obviously we will get 1 over x2. This is the expression of the conditional distribution of x1 given x2. इसके बाद अगर हम कंडीशनल मीन और कंडीशनल वेरिएंस की बात करना चाहें तो हम कैसे चलेंगे? The expected value of x1 given x2 will be the integral of x1 into f of x1 given x2. जैसा मैंने आपको पहले कहा था वही आप इसमें अप्लाई करें. So what do we get this time? It is now the integral from 0 to x2, and the integral is being taken with respect to x1, and the expression inside the integral is x1 into 1 over x2. क्योंकि वो conditional जो है, अभी थोड़ी देर पहले मैंने आपसे कहा कि that has come out to be 1 over x2. अब ये आप solve कर लीजिए. Obviously, if you are taking the integral with respect to x1, then x2 will act as a constant. और आप x1 का square divided by 2 करेंगे, साथ x2 भी है उसके बाद आप limits apply कर लें. Finally, what do you get? You get x2 over 2. और यहाँ पे मैं आपको एक बहुत अहम बात बताना चाहती हूँ. ये जो आपके सामने आ गया है, expected value of capital X1 given small x2 equal to small x2 over 2, और उसके साथ हम लिख सकते हैं कि small x2 is going from 0 to 1. तो ऐसा लगता है कि जैसे ये कोई PDF की तरह की चीज़ है. No, it's not like that, my dear students. ये सिर्फ इतनी सी बात है कि x2 जो है, ये जो वेरिएबल है x2, it is possible for it to assume any value in the interval 0 to 1. कोई भी वैल्यू जो आप रखेंगे उसके मुताबिक वो कंडीशनल मीन आपको मिल जाएगी. फॉर एग्जाम्पल, suppose that we are considering x2 equal to 0.5, यानी 0 से 1 के बीच का कोई भी नंबर हो सकता है ना. तो फर्ज कीजिए कि इट इज 0.5. उस केस में ये जो एक्सप्रेशन है, it will take the following form. The expected value of capital X1 given x2 equal to 0.5 is equal to 0.5 divided by 2, यानी half divided by 2, यानी 1 by 4. यानी कंडीशनल मीन आ गई है equal to 1 by 4 in that situation when x2 is being taken equal to 1 by 2. This is the manner in which you should interpret a conditional mean. Similarly, similar situation for the conditional variance. अब इस एग्जाम्पल में अगर हम variance निकालना चाहें तो क्या होगा? We will have the variance of capital X1 given small x2 this as the integral with respect to x1 of x1 minus x2 over 2 whole square multiplied by 1 over x2, and the integral will be going from 0 to x2. इसको solve करें तो expression बनता है x2 square over 12, और x2 जो है that can assume any value between 0 and 1. So, my dear students, this is how you deal with and compute and think about things like conditional mean and conditional variance.